and you can see what each individual subscription provides in terms of compute hours. And so you might actually discover you have enough resources provided with your MSDN account that you can actually run a virtual machine in Windows Azure 24/7 for all your development needs. So you don't even have to pay for it if you're already MSDN. If you want to sign up, just click the free trial button. It takes about 2 minutes in order to go end-to-end in terms of sign up. If you are an MSDN subscriber, make sure you enter in your live ID that's associated with your MSDN account. As part of the sign up process, we'll identify you're an MSDN subscriber and automatically credit your monthly hours for you. And so you don't even have to tell us you are. We'll detect it as long as you use that same MSDN account. Once you sign up, this little tab up here at the top right, instead of free trial, will just say portal. And when you click that, you can drill into an admin experience that provides kind of a unified view for all of the Windows Azure resources that you use. This is the new admin preview that we're going to be using today. It provides kind of a view across everything that you do within the system. You can drill into any individual feature, like you saw in the keynote here this morning, where you can kind of drill in and see what's going on in a particular VM. And you're going to see a lot more of this throughout the day, and we'll come back to this pretty regularly as we build our sites and solutions. First thing I just want to do, though, is kind of the canonical getting started hello world. For people that didn't see it during the keynote or who are joining us online, and just start out and create a new virtual machine. So Mark in the keynote showed you how you can use a gallery to create a new VM. We can go ahead and create one here. I'll just say TechEd VM. Choose an image. Our quick create option lets you basically in one click go ahead and create something. I can choose what size VM I want to create. I can choose where in the world I want to deploy it. So I'm just going to say West US. Hit create virtual machine. And that's literally all I need to do in order to stand up and start deploying a new virtual machine within Azure. So literally just seconds in order to actually go ahead and get started and create that. Once I have one of the things that you can do is just drill into that VM, see the health and diagnostics of how it's doing, and then just click this connect button in order to connect to it. Doing so will download for you an RDP file that if you click open, will let you log in. This is the hardest part of the keynote, which is remembering the password. Once you do that, we can basically establish connectivity to that VM. And this is a machine, I think it's running in the East US, although again, I can place it anywhere around the world. And I'm now logged into a Windows Server 2012 instance running on Windows Azure. I'm full admin on this box, so everything I can do on the machine as if it was local, I can now do inside this remote desktop session. And so I can install any software I want. I can install SQL, I can install SharePoint, I can install BizTalk. And if I shut down and reboot this VM, it'll still be there the next time it boots up. So it's a durable VM. Everything that's written to disk is persisted. And I basically own that image, and I can do anything I want with it. So it ends up being kind of really powerful. In addition to creating an OS instance and installing stuff in it, I can also, there's that VM we created. It just looks like it's already created. I can also attach what are called disks. And so I can create empty data drives that I can then mount on top of any of these VMs. And when I do that, I can then go back into that image. It'll show up just like a disk, and I can format it with NTFS, and I can install any software I want as part of that data partition. And the beauty about all these different disks, whether it's the OS image or whether it's the data disk, is I have direct URL access to it. And so if I want to, I can later, and I'll talk about this more in a little bit, I can download this VHD and just boot it up on hypervisor running on my local server environment. So it ends up being really flexible. I can basically do anything I want with it. So you saw me create a Windows VM. It wouldn't be TechEd without us also showing how you can create Linux. It's probably a first, actually, for TechEd. But one thing you can do also from the gallery here, if I go ahead and choose this images, you saw a number of Windows images that we could choose from. I could also, if I want to, pick from some of these other distributions coming from some of our partners. And so in the same way I could create a Windows VM, I could go ahead and say, SkyGoo Linux. We'll give it a password. Pick a core. I can optionally upload an SSH key. And we'll call this deployed also into the, let's do it in the East. not Asia, let's put it in the US. Click next, click go. And that would create a virtual machine. I must have put it in the wrong data center. See one that's already created. Let me drill into this one here. And I can go ahead and say SSH, Scott, Ubuntu 12.cloudapp.net. The username is Scott. There we go. And so this is going to connect for me to this VM I already have. And there I am, logged into an Ubuntu instance running in Windows Azure. See what processes are running. I can see what's running on the system in terms of resources. And again, I'm full admin on this box in this case with this username password. I can install any software I want in it. I now have the ability to run anything I want within Windows Azure across any distribution. I have complete control over it. So lots of different options, lots of different flexibility. And once you actually stand up an image and configure it, you can also click this capture button in order to create a reusable template so that you can create any number of these VMs really easily later on. So that's a quick view of virtual machines. If we go back to the slides now, let's talk a little bit about behind the scenes, what's happening under the covers. So as I mentioned, works with any OS, works with any distribution, supports pretty much any workload. All of our standard Microsoft software products, we're basically testing and certifying on Windows Azure. So you can basically, again, take advantage of SQL, SharePoint, BizTalk, or other server workloads. One other thing, actually, I want to go back to really quickly, actually, I could go back to the demo I want to show off, is also our virtual private networking support that we have. And so not only can you create these VMs in the cloud, one of the other things I can do, which is really nice, is stand up a network. So how many people here have a virtual private network for their enterprise? Okay. How many people here use a hardware-based VPN solution? How many people use software? Okay, mixture, okay. Probably a variety of different technologies used to implement that networking technology. Let me show you what you can do with Windows Azure. You can go ahead and say create network, and we could say, let's say demo VPN. I could stand this up, I could hit next. I could provide an address space as well as a set of subnets to basically stand up and point to a VPN solution that's running within an enterprise. And by defining this, I'm going to basically create a network within Windows Azure that I can join my corporate network to. And I can define whatever IP address range I want to use for that network. We'll virtualize it so that if we have two customers running in the same data center who happen to pick the same IP address, we'll isolate them on the network so that they don't see each other. I can specify DNS and a bunch of other things, and this will kind of graphically create this diagram at the bottom here, which specifies my network. Now, I'm not going to make you watch me type that in. Instead, though, I'm going to show you an existing one that we already have right here. And so this basically, I've defined an IP address range. I'm pointing back to a corporate VPN network, and I've got a DNS set of servers inside my firewall and my corporate network that my machines are going to have access to. And once I define this, within the admin tool, I can then click the download button in order to configure this so that I can connect to my solution within my enterprise. So how many people here have a Cisco router for VPN? How many people have Juniper? Number? Lots of other different solutions. We basically allow you to pick what type of solution you want to use, what router type you have, and then just click download. And what this is going to do is generate for you the config script that you can then give to your network operator that owns that router, run it against the script, and once that script completes, that network will be joined with Windows Azure. And that means that any of the servers that we hosted within Windows Azure, your customers on your existing intranet can get access to, and likewise, you can open it up so that any of the servers you run within Windows Azure can get access to network resources on your existing enterprise network. And it's completely seamless, completely secure channel, and you can basically now connect the two environments. So let's go back to the slides. Other nice thing about this that I touched on briefly when we were creating the virtual machines is this portability aspect that we bring with Windows Azure. And specifically, we're using the same VHD file format that we use with Hyper-V. And what this means is basically any of the VMs that you have running on Hyper-V today within your existing data center, you can basically upload now to Windows Azure and boot up and run. And likewise, you can take any of the VMs off of Windows Azure, boot it up on your local server environment, and run. And you can integrate with other service providers that are running Windows Server. And likewise, you can basically take any of those types of VMs that you have either locally or in Windows Azure and move over. And that ability to do kind of software portability or VM portability we think is really powerful and kind of ensures that you have no lock-in and lots of options regardless of how you choose to deploy and manage your workloads. Other cool thing about Windows Azure is I showed briefly in that demo how you could attach a disk and mount it within a VM. We call these persistent drives. And it basically, from an OS perspective, it just looks like a standard drive that you format and mount on a disk. Under the covers, though, we actually back that drive with what we call the Windows Azure storage system. This is a storage system we use for lots of different scenarios, and I'll talk about some more of those a little bit later on in this talk. One of the nice characteristics of the storage system is it's built with kind of failure tolerance in mind. And so when you actually mount a drive, we store that data on 3 separate disks within the storage system. And we replicate everything in triplicate. And what that means is if one of the drives ever fails, we can switch to the other 2 copies and without having any interruption to your VM, without having to restart your VM, without any type of glitches. It's just kind of a seamless failover. Other nice thing about this system is we actually, by default, back up your data to another data center in an asynchronous way. So within a couple of minutes, anything you write to that drive will be copied to another data center at least 500 miles away, so that in the event of a complete region failure, so if there was a natural disaster or for some reason an incomplete area that the data center was in was knocked offline, you know that your data is at least 500 miles away, and you can begin kind of a recovery operation in order to stand up new things. And this just happens for you automatically. You don't have to set it up. If you don't want to, you can turn it off. But it provides kind of some nice safety and peace of mind that you can rely on to kind of stand up very powerful and reliable systems. So that was a little bit about virtual machines, lots of new capabilities coming there. Again, Mark's going to have a great talk this afternoon. He'll go into more detail about it. I'm going to switch gears now and talk a little about our website functionality. I demoed that a little bit in the keynote this morning, and I'm going to go into a little bit more depth here today. Our website functionality is a new managed service that we're standing up within Windows Azure that you can take advantage of today. It allows you to very easily build sites with ASP.NET, Node.js, PHP, and we'll add more options in the future. One of the benefits of it is that it allows you to deploy in seconds, and you can use FTP, you can use TFS, you can use Git, and you can use web deploy directly inside Visual Studio in order to do it. Other nice thing about websites is it comes with a free offer. This is free not just for MSDN users, but for everyone, where you can actually host up to 10 websites at no cost within Windows Azure in a shared multi-tenant environment, and then you can basically scale up resources as your traffic grows and expand it to be even bigger. So it's kind of a great dev experience that you can take advantage of that gives you kind of a lot of goodies to play with. And so I'm going to go ahead and just show off a very quick demo of how you can take advantage of that and do it in action. So back in the same admin tool that we were in earlier, I'm just going to create a new website. What would you like to call the website? Dude. Okay. Dude. We're going to create the Dude website. We'll hope the Dude is working. And one of the things that's kind of nice about creating websites with Azure now is how fast it is. So just to prove that was real, we now have a Dude website running in our East data center in the US that I can drill into and see all the statistics about. And so literally, it takes on average, about 6 seconds in order to create a new site. This wired up a DNS entry, so this is literally live on the web. Now, we don't have any code in there, so let's go ahead and download our publishing profile and configure it. So I'm just going to save this publishing profile here. As I mentioned in the keynote earlier this morning, you can also wire up Team Foundation Server to do source control-based deployment. This is a super powerful option that allows you to set up a complete build and test environment integrated end-to-end. And you can do check-in gates so that if your unit tests fail or you don't have enough test coverage of a new feature, it won't deploy and instead send a mail saying, hey, test failure, go fix it. And then you can automatically set it up so that if everything passes and the build passes when you do a check-in, it automatically deploys to a site. And this works for both websites as well as what we call cloud services, which I'll talk about a little bit later. So we saved that publishing profile. We can go ahead and create a new dude website. Call this dude. Choose just a standard internet application template, which is kind of the default template that comes with ASP.NET MVC. And so we can just say, well, let's keep it the default template for right now. I'm going to go ahead and hit publish. I can import settings for this thing. Go ahead and hit publish. This is going to kick off a publishing process to Windows Azure. So it's going to go ahead and upload all of the files that we're deploying here. And it's saying that the deployment, it failed on me again, twice today. Dude, I know. Well, the demo gods are not with me on deployment today, apparently. But it would actually deploy very fast. Let's try another website, and we're going to call this, come on, dude. Again, it's really fast to create a new website. Takes only 6 seconds. And that was even faster than 6 seconds. But we're going to go ahead and download this publishing profile. We're going to go back into Visual Studio. It's called the dude. Or I'm dude. And we'll right-click. We'll right-click and deploy. Do another publish. And hopefully in just a few seconds. Dude. Well, anyway, we seem to be having a challenge in the East Data Center. But that will hopefully work in terms of deployment later. But it would be really fast. You saw in the keynote this morning. And the other cool thing about it is redeployments work really fast. And so you can go ahead and take advantage of that. So one other thing you can do, well, I tell you what, someone's saying, why don't you switch to a backup because they have it working. Oh, there we go. But basically, this deployed to one of our backup machines. Let me just show one quick thing here, which is let's change some text. So this deploys, and one of the things you'll notice here is when I do publish, one of the features that we have built in is this notion of kind of differencing. So someone deployed this backstage and it worked. I just made a change. I'm going to go ahead and redeploy it. And you'll notice that it's saying, hey, there's only one file that's changed. I can go ahead and hit publish now. And one of the things that's nice about this is it's going to open up this page. And you'll see, again, changes take pretty fast. Only takes a few seconds in order to do a deployment. And you can see it just says, let's change some text. So it basically matched what my change was. So the cool thing is deployments are really fast. Even when it wasn't working, it was really fast. But even when they do work, it's really fast. And otherwise, changes are really fast as well. And so this ability to kind of make a change, quickly redeploy, and see it live in action ends up being hopefully a really powerful thing you can take advantage of. A couple other things you can do as part of this. Look really quickly here, you can see we get built-in statistics that are showing the stats in terms of number of requests hitting this application. So you always get kind of real-time view in terms of how many requests are coming in, how much bandwidth is going out, how much file system memory is being used, and so forth. You can also configure things. So you can look at the monitoring tab here, and you can see kind of more of a readout data. You can see the number of HTTP errors within the system. You can also go ahead and configure what version of .NET you want to use. You can map custom host names to it. You can turn on diagnostics and logs. And the logging stuff's pretty useful because once you turn it on, you can actually download the HTTP logs from the site directly in the portal and actually view literally what the traffic is going on within the system. Other thing you can do is click the Scale tab. And this is, I'm going to go into more detail about this in just a second, but it's a pretty powerful kind of capability. And it effectively allows you to start with this sort of free offer, which is what we've been deploying to, and then elastically scale up as you need once your traffic goes up. So you can keep an eye on the monitoring tab. You can see the number of requests per second. You can see if you're going to exhaust the resources that come with the free shared account. And then when you want to add more resources, you can either scale up the number of processes running in the shared cluster. So you can have 3 instances running in our shared cluster. Or you can click this Reserve tab. And what the Reserve tab does is it allows you to say, I want to deploy a couple of virtual machines that host this app. And so I can just literally say, change to medium. I can go ahead and say, I want 2 medium-sized VMs that are dual-core, 3.5 gigabytes of memory. And I just have to hit Save. And this will actually start Windows Azure scaling out my website across those 2 instances. And that's going to take, on average, about 20 to 30 seconds. It's actually already done, that little blip. Now I'm running in reserved mode. And now if I throw a lot of load on the system, I've got a lot more capability backed up for me to go ahead and take advantage of it. And the other nice thing about reserved mode is only your apps run on that machine, so you don't have to worry about other tenants potentially impacting your performance. So we go back to the slides. Let's go ahead and walk through kind of architecturally what that means. So as I mentioned, we have a shared mode. It's free. You get up to 10 free websites that you can use within it. And so you can deploy a site. You're one of many inside these shared infrastructure VMs. You can scale up the number of sites, so you can have multiple instances within that shared environment, or you can flip into reserved mode, at which point we'll have dedicated VMs running for your applications where you're the only tenant inside that virtual machine. And you get to choose what size VM you want to run, and then you can say, I want 2 instances of those, 3 instances of those, or scale it back down. Nice thing about the Windows Azure model is you only pay for what you use. And so we actually charge for VMs on a per hour basis. So if you scale up for an hour to 3 extra large VMs because you've got a special event going on, and then at the end of the day you scale it back down to 1, you only pay for those 3 VMs during those hours that you're actually running it. And it's only costs pennies per hour. And so you have this ability to kind of scale as you need it and only pay for what you need. Other nice thing about reserved instance VMs is you can run multiple sites on it. So you could run the dude and the come on dude in the same VMs. And again, only your VMs are running in this reserved instance model, but it provides a nice way that if you're building sites for others or you have multiple sites that you want to develop, you can run them all in your own infrastructure and then again, elastically scale up or down as you need it. Very cost effective, very easy to use. So that's a little bit about websites. Let's shift gears now and talk about cloud services. This is another way that you can use to build solutions on top of Windows Azure. So we talked about VMs, we talked about websites, this is the third. And cloud services basically give you even more power and flexibility that you can take advantage of. They allow you to build what we kind of call infinitely scalable apps and services, which is a pretty bold statement, but translates into literally you can have thousands of VMs running as part of an app solution, and it will all work. It also supports the ability to kind of what we call rich multi-tier app architectures. So in other words, if I want to have front ends and back ends, where I have kind of middle tier or kind of REST-based services or SOA-based services on the back end, I can orchestrate them all into a single solution and deploy that entire thing as a single app and manage it as a single app. And it's fully automated. So it handles deployment, it handles scale out, and I can literally scale out each individual component to hundreds or thousands of VMs. And just like the other 2 models that I talked about, it uses the same pay-as-you-go kind of model. So you're only paying for what you're using. And so we have some customers that spin up cloud services that literally use 10,000 VMs overnight when they're crunching data for Wall Street. And then at 6 a.m., they shut down to only about 10 VMs during the day. And then back at night when the market closes, they spin them back up and they analyze and crunch the data again. And that ability to kind of increase and decrease on demand to any scale really opens up a lot of possibilities. So let's go ahead and see a demo of this in action. So we're going to go back to our admin tool here. And let's actually go back to our Dude app and walk through what it would take in order to actually convert this to be a cloud service and scale it within Windows Azure. So converting an existing website, whether it's an ASP.NET project that's never been deployed on Azure or one that we've deployed to a website, is really easy. All I need to do is just right-click on it and say Add Windows Azure Cloud Services Project. This will add into my solution inside Visual Studio another project, in this case, dude.azure. This basically contains some sort of metadata about all of the different kind of what we call roles that are running in my app. And now, right now, I just have a front end called dude within here. Let's go ahead and create a back-end service. And I'm just going to basically model this thing as a middle tier service that either my front end could talk to, or maybe it's going to process messages off of a queue. So I'm just going to say new worker role, and we'll call this the dude backend. We'll just call it backend to make it easier. Backend of dude. There we go. I'm not sure that's politically correct, but anyway. We're going to scale that up later. Let's move on. So we got two projects for our front end and our back end now inside our solution. We've got both of these roles defined within this this cloud project. One of the things I can do is, as a developer, is I can bring up some metadata about these roles. And so I can actually choose as a developer, what do I want my initial deployment size to be? And an admin can override this, but I'm just going to say I want by default 2 VMs. I can control what security policies I want to use, so I can set up a firewall around this application so that the front end and the back end can talk to each other, but no one else on the internet can talk to the back end. I'm going to say this back end, let's do 2 as well. And likewise, I can choose what size VMs I want to run it in. So we have a bunch of different VM sizes. So I could say 2 core, 3.5 gig, or I could say 8 core with 14 gigs, et cetera. And the nice thing is, from a developer perspective, I can also go ahead and build this project and run it locally inside an emulated environment. So I don't have to actually deploy it to the cloud in order to see how it goes. I can just sort of hit F5 locally in order to spin this up. When I do this now, it's going to launch a local emulator on this machine. Let me just bring up the window. You can see here now it's actually running inside this browser using a 127 address. And if I click down here and say Show Compute Emulator UI, we'll bring up this emulator UI that has details about this instance that's running. And now remember, this is simulated across 4 VMs. And so within the emulator, I actually have 4 simulated role environments. And I can actually drill into any of these in order to see kind of debug output spew from that particular VM. So it makes it really easy to kind of build apps locally without having to deploy anything. And I can simulate what it'll be like in a cloud environment. Now, when I want to go ahead and deploy, it's pretty easy to do that. I just right-click on this project, and I can hit Publish. And just like I could with websites, I can walk through this wizard, and it'll go ahead and upload this application to Windows Azure and deploy it in the cloud. Let's go to the slides and then walk through kind of what happens when I do that. So let's go back to the slides. Yeah. So what will happen is when I use Visual Studio, compile and upload an app, we're going to create what's called a service package. It's effectively like a zip file that contains all of our app code and definitions of what we want to have Azure deploy. Now remember, this app is a multi-tier app where we have multiple nodes in multiple places. And so Azure will take that definition and find us 4 VMs that we want to run our roles within. And then once it identifies those within the data center, it's going to take the code that we deployed, and then it will basically deploy it on top of those VMs. It'll stand up IIS, it'll install any certificates necessary, it'll wire up a firewall across all those different VMs, and then ultimately it's going to plug it into a load balancer and make that app available on the internet with a public IP address that someone can point to. And once I do that, my app is deployed and I'm ready to run. The beauty is it's all automated, so I don't have to worry about, and the VMs are actually wiped before each deployment, so I don't have to worry about a registry key that was set from some other piece of software that I forgot to delete. I don't have to worry about something kind of working sometimes if I didn't patch it right. It's always automated. It always runs through the same process, and so you have some guarantee that you know that you can always deploy that app with high confidence. Other thing that's nice about Windows Azure is we're monitoring these VMs automatically when they're running. And if we ever detect a failure on the VM, either because of the OS problem or a hardware problem, or if your software goes bad, we'll automatically detect it, pull it out of rotation from the network load balancer, spin up a new role in a new VM, get it all ready using the same app code that you deployed earlier, and then bring it automatically back into rotation. The benefit here is you don't get a pager in the middle of the night. Your app never goes down, and your customers have high confidence that your solution's always going to work, and Windows Azure does all that for you. We even deploy, when you actually deploy these VMs in the data center, we'll make sure that we'll actually, if you have 2 front-end nodes, we'll make sure that each front-end node is running on a separate rack with a separate power supply, with a separate server, with a separate top-of-rack router, so that even in a hardware failure case, where a router goes bad or a power supply goes bad, your app never goes down. We'll actually automatically pull that node out of rotation and send all other traffic to it and spin up a replacement. And that's one of the big benefits the cloud service model provides. Other nice thing is then the management capabilities that it provides. And so we go back and let's just take a look at what we're providing as part of the release last week and some of the good updates and enhancements it brings. So in the same way I can drill into a VM or I can drill into a website and see statistics, I can also now drill into and see data about a cloud service. And what's nice about this is I can see kind of aggregate view on that home page. I can also drill in on the monitoring tab and look at individual instances and see how they're doing. And I can also add my own custom metrics and surface them directly within the portal as well. So I can see a bunch of different statistics here. I can click Add Metrics, and we now support a whole bunch of metrics that you can use. And so I can do it on a per instance basis or aggregate. I can look at data in, data out, disk I/O, IIS meters, all those things are built in. Cool feature that we shipped last week as part of SDK is also the ability for you to define your own custom app metrics. So if you have orders per second or customers signups per second, you can also surface them within your app code, and the Azure admin portal will automatically reflect those, and then you can actually see what your app health is doing in real time as well. You can configure anything, this is what's on the system. You can also scale it out. And so this kind of goes to kind of that elastic scale capability. Just like you could with websites, I can scale out these VMs. But the nice thing about this is a cloud service can have multiple tiers. So I could have 2 or more roles defining front-end, back-end, or different types of back-end services. So if I want to make this back-end service really big, I can go ahead and scale it up to, say, 400 VMs or more. This is only limited by how many cores are allowed on your subscription. This subscription allows up to 400 cores, and so you can see I can have, say, 300 on the back end, and I can scale up the front end quite a bit as well. And so once I hit save, Azure will start deploying those across all those instances. Just because I don't want to spin up 200 right now, I'm going to spin it back down, but allows you to do that. You can also go ahead and, for any of the instances you run, you can click on them, and just like I could RDP into a virtual machine, I can also RDP into a role instance, and so I basically can terminal server in and be full admin on that box and actually see what's going on in the instance health. So a lot of management capabilities all built in now into the admin tool, and it makes it really easy for you to build, stand up, and deploy these types of services in a really reliable way. So let's go back to the slides. And keep going. So one of the things that hopefully you're seeing through some of these demos is how kind of with Windows Azure, we kind of embrace this model we call focus on the apps, not the infrastructure. Meaning, how can we enable you to not have to worry about some of the infrastructure details and instead focus on both developing the app and then also monitoring and managing the app from an app lifetime perspective in a nice unified way. And you kind of see this kind of throughout the system, and it ends up being super powerful from a productivity perspective because it means that, you can just take a dev environment. If you need to quickly spin up a VM for dev and test, you can now just go to the portal, quickly stand up that infrastructure, and use it. If you're deploying an app and your business takes off, and you go, oh, we got a big sale coming on next week, you can spin up more resources immediately and take advantage of it. And likewise, you can spin things down when you don't need them. So that dev test environment, at the end of the day, you can turn off until the next morning and not have to pay any bill. Likewise, when the sale is over or a seasonality kind of event is over in your business, you can scale down your resources because you don't need as many and you don't have to pay for it. So it ends up being super flexible. Other thing is these sort of application building blocks that we provide so that you don't even have to think about standing up a SQL database. You can stand up a database service inside Azure, and we'll take care of a lot of the plumbing behind the scenes and allow you to kind of just focus on running your solution. And these application building blocks I have on this slide are just sort of a small sampling of some of the different types of solutions that we provide as managed services within Windows Azure. They all have SLAs, and they give you kind of as developers a lot of flexibility in order to program against them. You can use these from any SDK, so we have lots of different languages that you can take advantage of. All of the SDKs for these services are also released under an open source license on GitHub. So we still provide full product support for them, so you can call up anytime Microsoft support. But you can also, if you want to see what our code looks like, you can now download it. And we also use GitHub to actually ship more agile releases. So if someone has a bug fix, we can actually push it out, and you can sync it immediately and incorporate it within your app. So what I'm going to do is spend just a few minutes walking through a couple of these services to give you kind of a flavor and sense of what you can do with them. The first one I want to kind of walk through is called a SQL database. And basically what this provides is a relational SQL Server engine that you can use in the cloud. It's fully clustered for high availability, so we run your database across multiple machines in case one goes down. And it's a fully managed service, so we're doing all the patching for you. We do the backups. We basically take care of the cluster. And you can just say, I want a database, and stand it up, and then we do the rest. You can use the standard ADO.NET, standard SQL programming model against the database. You can use the standard SQL Management Studio in order to manage the databases and create databases within it. Starting with this most recent release we've done, we now have SQL reporting services support. So you can also do reporting against the database and use the standard SQL reporting capabilities that you're already familiar with. So let's go ahead and see a quick demo of it in action. So just like I could create a virtual machine, website, a network, a cloud service, I can also create a SQL database. Should we call this the Dude DB or DB Dude? I don't know. I can do that. I can go ahead and create. This is going to stand up for me a new SQL database, and it's created. And it's sort of, well, what then? Well, that actually is it. We now have a database, DB Dude database that's created. I can now deploy any database I want within it. That was how easy it was in order to create and manage this. If I want to scale this up, right now it's a 1 gig database. Let's make it 150 gigs. All I have to do is hit save. Another 20 seconds later, this database is now scaled up to be a 150 gigabyte database. And that's pretty much everything I need to do. I can get my connection string access to it, so I can just copy and paste this and use it from within ADO.NET. And I can access this thing from a virtual machine, with a custom virtual machine running Windows that I'm running. I could access this from a website. I could access this from a cloud service. And makes it super easy to stand up these types of databases. And that's, again, how quick and easy it is. And we're doing all the clustering, all the backup, all the load balancing for this database and making it run. So that's one example of a database service. Let's talk about some of the other services and go back to the slides and that you can take advantage of as well. In addition to kind of relational data, we also have a really powerful storage system. I talked about that earlier in the context of cloud drives that you can mount on VMs. You can also take advantage of what we call a blob storage service that we provide that gives you a highly available, scalable, secure file system in the sky. And what's nice about the blob system is you can store any data you want within it. So think of it literally as like files or blobs. And you can optionally choose to make those blobs publicly accessible over HTTP. And so the nice thing about the blob service, if you're like, storing documents or images or CSS that you want to expose to anyone, you can write to the storage system and then hand off a URL to it that you can give others access to. And just like the durable drives, we're doing continuous geo-replication so that we're backing it up in the background for you. And if I create a storage account, just like the SQL account, it only takes under 60 seconds. And we also provide full stats as to how many people are accessing the storage system. We also, what's cool, is surface the SLA now directly in the diagram. So you can actually see, is this storage service performing to the level expectations I want? In addition to checking for availability as part of the SLA, we also measure the latency. And if the latency ever gets too slow, we'll actually count that as an availability issue and surface that directly in the admin tool. So you can really kind of do with confidence and monitor it really easily. In addition to database and blob storage, another type of storage that I want to talk about a little bit is the cache. We have a distributed caching capability built into Windows Azure that you can take advantage of. And the release we did last week adds to it a whole bunch of new capabilities. It's a low latency in-memory distributed cache. So it means that anything you store in this cache is kept in memory within your application. It's designed, because it's distributed, that you can use it across multiple machines within your environment. So if you have 5 web servers, they can all share the same cache. Any data that's put into the cache by one web server can be accessed by another web server. And so it's shared across all of them. It's not a per process cache like, say, the built-in ASP.NET cache. It's also designed to dynamically grow and shrink. So you can increase and decrease the cache size depending on what your application needs. It supports what's called high availability. So when you stick something into our distributed cache, you can say, make sure this is copied on at least 2 more nodes. And that way we'll copy that cache item onto 3 servers. And so even if 2 of the servers crash, you have your data saved somewhere else that you can recover. And it supports the full App Fabric Cache API, and so you can take advantage of it. It also now supports the Memcached protocol, which is another popular open source cache system. And so if you have code written against Memcached, you can just point it at our cache, and it'll just work. So let's see a quick demo of this in action. So I got a simple app here called Twitter Reader, which basically is accessing Twitter and showing real-time tweets from Twitter, which is always a little bit dangerous because Twitter is not always up. And so, oh, good, it's up today. But you'll see basically it took about 1.6 seconds to retrieve that tweet from Twitter. If I hit refresh again, we'll see 1.6 seconds. Sometimes it goes up to 4 seconds. So this is retrieving data in real time, showing it in this little browser app here. Now, this is useful, but taking 1.6 seconds to have your app call another service is going to cause scalability challenges when you throw a lot of users at it. And so what I want to do instead of hitting Twitter each time is store the tweets in a cache and only invalidate and hit Twitter, say, every 5 minutes or every 2 minutes or so. And with the distributed cache capability built into Windows Azure, it's really easy now to do that. All I need to do is, I'm just going to go back into my project here and pull up the settings for my web role. And you remember this is where we increased the number of instances that we were running in the earlier cloud service section. With the release we just did last week, we also now have a caching tab that you can use in order to enable a distributed cache within your app. All I need to do is just click the Enable Caching checkbox. This goes ahead and sets up a cache within my VMs. I can choose how much memory I want to use. That's enough for now. I can then go in my Twitter Reader app. I'm going to use the NuGet package manager, and I'm going to add the caching assemblies into my .NET solution. So now I have the caching APIs there, and then I just need to go and do 2 things. One is I'm going to update my web.config file to point to my app. I'm just going to say Twitter Reader is the name of where my cache is located. I'm going to enable this option called the local cache, like so. And I just need to update my MVC app in order to read and write stuff to and from the cache. And so to do that, I'm just going to open up this controller. Right now, you can see I'm always getting the tweets from Twitter. I'm going to replace that line of code with a little snippet here. And what this is going to do instead is use the new cache right here and check to see whether or not the tweets are already in the cache. If so, it just returns them. Otherwise, it gets them from Twitter and then adds them into the distributed cache. And now I can rerun my application. There we go. I can rerun my application. There it is. Hit refresh. And we're going to go out here the first time and hit this feed. And so Twitter now is 5 seconds. This is the first time, though, so this is uncached. Hit it again, and you can see the cache is starting to kick in. And now, when I'm refreshing this page, I'm actually rendering it in under half a millisecond. And that's because I'm able to basically take advantage of the distributed cache to pull those tweet data, and only every 10 minutes or so will I go off and actually retrieve a new copy of the data. And so it's that easy to enable this distributed cache. The beauty is if I have 4 web servers running in my system, it doesn't matter which web server gets the Twitter data. As soon as it puts it in the distributed cache, the other 3 web servers can get access to that same data. And I can store anything I want inside that cache. Any of my business critical data I can put in there. We support invalidation, so if the data ever changes, we can automatically invalidate it. And again, the full App Fabric cache server capability, it's really easy to take advantage of. So let's go back to the slides and talk about, again, architecturally how this works. This demo I just did takes advantage of what we call a co-located option, which basically means I can run the cache within my individual web servers or my worker machines. Beauty here is I'm taking advantage of memory I've already paid for. So I already spent up these 4 VMs. I can choose how much memory within the VM I want to use. If I say 300 megs on each, and I have 4 instances, I have a 1.2 gigabyte distributed cache that I can put stuff into. And again, any machine can put data into it, and it'll be distributed across those machines. Beauty about that environment, it's effectively free. I'm not having to pay any additional money in order to enable it. I can also enable worker roles to have the cache in it. And so I can run these things as effectively dedicated workers with just the cache. So I could have a 12 gig cache and 2 roles. I could go back into that admin portal like you saw earlier. I could scale up the number of caches I want dynamically. And now I could increase it to 48 gigs of cache. And the cache service outputs perf counters, so I can see how much of my cache is available. And I can do this based on whether or not my cache needs more memory or not as an admin operation. So really easy to kind of scale up or scale down, really cost effective, gives you a lot more juice within your application. Other kind of services that we support as kind of building blocks. One is called the identity service. This makes it really easy to integrate the solutions you deploy in Windows Azure within your existing corporate identity architectures. And so specifically it enables single sign-on within your apps, where anyone that visits the website, even though it's hosted in the cloud, can use their standard Active Directory credentials to sign on to the apps. It also enables what we call an enterprise graph API that allows you to query for users and actually retrieve their Active Directory information as a REST JSON document. And you can do this either within your corporate apps in order to get access to say, what groups do they belong to, or who's his manager, what office he's in, so you can make your apps have more identity built in. You can also optionally, if you want to, expose it to other SaaS-based solutions that your company subscribes to. And that way, if you buy an app from an ISV, you can say, hey, I'm going to give you access so we can do single sign-on within our corporate Active Directory, and I'm going to give you access so that you know what region I live, this employee is in, and they can surface and take advantage of that within their app. You have control over what information is exposed. The end result, though, means that apps get a lot richer and have much more knowledge about the identity of the individual users. Other kind of service I'm going to talk about here is called the Service Bus. This enables secure messaging and relay capabilities. I showed that in the keynote this morning, the queuing capabilities that you can use with the Service Bus. I'm going to show a slightly different demo now, which takes advantage of some of these relay capabilities. And the end result with the Service Bus is that it enables you to much more easily build hybrid apps. So you can have some of your app code running inside Azure, some of it running on Windows Server within your existing data center environments or in another service provider. And it also enables a much more loosely coupled-based solutions so that if, for example, my back end goes down or my front end goes down, I don't have a complete app failure. I can actually just queue messages and continue. Or in the relay capability, I can actually fail over to another location. So the app I'm going to build here is pretty simple. I'm going to basically give you show a simple app where we have a front end that could be a mobile-enabled app. And I want to connect it to an app running inside my firewall within the enterprise that's connecting to a database. And for some reason, say I don't either trust to move the database to the cloud, or it's such a large database, or it's running on existing hardware we've already paid for, I don't want to move it to the cloud. But I'd really like to be able to expose some of that data or use some of that data within cloud-hosted applications within Azure. So what I can do is I can wire up what's called a Service Bus Relay, where I can set up a channel, secure channel that'll connect my app running in the cloud with my app running locally behind my firewall. And I can choose to expose whatever data I want on that channel. It's not like a VPN where everything's opened up. Instead, I just define a SOA endpoint using WCF, and I can expose just the operations I want from that application back and forth. So it makes it very secure. And now then, if I have a front end that wants to access that app, I can do that in a very secure way. So let's go ahead and see a quick demo. So I'm going to basically what I've done is I got a simple Northwind database running on this local machine, and I've defined a customer contract service within WCF that has 2 operations, one called get customers and one called get customer by ID. And I'm just implementing it here with this WCF service that looks like this. So it just uses the entity framework to query the database and return data. So a very simple service. And then I have a program.cs file, and this is literally everything that's in there. And all it does is it connects to Azure using these service bus APIs, exposes this WCF service to it, and then just says we're available and waits for someone to hit enter. And so when I run this now, this console app is going to run. You can see we've connected to the database, we're connected to Windows Azure, and I'm now publishing this customer service from my local behind the firewall environment to the cloud to Windows Azure. What I can then do is from within any apps within Windows Azure, I can then connect to this app and pull data from it. And so I can basically just build a standard, say, MVC web app, or it could be any type of app. It doesn't have to be specific to ASP.NET. And I can connect to this endpoint that's been published in the cloud. And when I do that, I am now able to kind of see this UI right here and pull back some customer data. And what you can see, if you go on the right-hand side here, is I can basically browse in and out of this customer data. And when I'm doing this, notice this customer's operation shows up. And what's happening is the thing on the left is running in Windows Azure in one of our data centers. The thing on the right is running on my local machine behind a firewall. And I can now, within the app on the left, fully navigate this data. Each time I do it, my web app is actually not calling to a database inside Azure, but it's actually tunneling all the way into my enterprise and calling the appropriate request in order to retrieve that data. The beauty here is now all the data that I want within this app doesn't have to be published on the internet, doesn't have to be exposed inside the cloud. I can run on the existing environment I already have, whether it's a SQL database, an Oracle database, a mainframe, or what have you, and I can securely expose just those two operations that I wanted to make available to apps within my application. And of course, I can lock down this service so that only my applications get access to it, so I'm not publishing this for everyone. I have the same kind of security credentials I could use just like on-premise. Windows is saying, hey, you sure you want to enable that through the firewall? Yep. And so now basically just those two operations are exposed. Again, I can ACL them however I want. So this is a really powerful way that you can take any existing data or any existing app you have already running within your enterprise, publish it up to the, expose some of that functionality to the cloud, and then build cloud solutions, whether they're running in a VM, a website, or a cloud service that you can take advantage of. Let's go back to the slides. So just walk through a few kind of quick number of these types of services. The beauty is there's lots more, and you're going to see us add more and more in the months and years ahead. And our kind of goal, again, at the end of the day is how do we make you more productive by providing you these kind of building block services that you can use, where we kind of manage a lot of that infrastructure, and then you can use from any type of environment you want, whether it's durable VMs, websites, or cloud services. You can use all these services now from more than 89 countries and territories, including obviously the US. And so you can basically sign up for Azure today in any of these countries, get payment in your local currency, take advantage of them, start building these solutions on the cloud. The end result, hopefully you've seen here, it's very flexible, very open, very, very solid. You can go ahead and deploy anything you want within it. And getting started is really easy. Everything I've demoed here today, you can download samples on how to do. You can go ahead and spin them up yourself. If you're an MSDN subscriber, you're already paying for some of those resources, and so you can take advantage of them for free. And even if you're not an MSDN subscriber, we have a 90-day free trial that you can sign up for that allows you to very easily get started. And you can do everything now by going to windowsazure.com. Looking forward to seeing what you create with it, and hope you have enjoy the rest of the day. Thanks so much.